Why did we want to buy a diode laser? There's several different options that you can have. Cost effectiveness, speed of operation, energy efficiency, size, reliability, high quality engraving, and etching on certain materials, wood, leather, anodized metals, etc. Now, we're talking here about the small lasers, diode lasers. These usually range from 10 watt to around 40. There are some new ones coming out now with 2-watt lasers, which are specifically for high resolution engraving. And as you see at the bottom there, it says, diode lasers are excellent for users seeking accessibility to an entry point laser technology due to their affordability and long lifespan. So they say they're particularly useful for intricate designs, and they're used by hobbyists and craftspeople right through to medical procedures and other technical things that are in industrial use. Now, the software that you need for most of the diode lasers are two different types of software. One, you'll need to design your image that you want to send to your laser. And the other one is the control program, which actually sends the image to the laser. Design programs, you've got Inkscape, Illustrator, CorelDRAW, Lightburn, Blender. There's all sorts of programs you can use, and some of them are free, which is quite handy. The control programs, as you can see there, they actually generate the G code that would move the motors and switch the laser on and off. The diode lasers, most of the diode lasers work on an ordinary G code sending program. So you can use practically anything you can just use Notepad to create a G program if you know how to, and send that to the printer and it will print. Other machines like the X tool and certain creative machines, they use a generic program. It's based on G code and it sends G code to the laser, but they have their own little quips inside them to keep them so that it will only work with X tool or whatever program. So if you want to create something, you'll need a design program to create your image, and then you'll need the control program or CAM program to design to send the design to the laser. And CAM, if anybody is not too sure, is computer aided machine. Right, types of laser. There are a lot of different types of laser. As you can see there, you've got gas, semiconductor, fiber, solid state, liquid, chemical, examiner, UV, and femtosecond. We'll only be dealing with the semiconductor one at the moment anyway, which is the diode one. That's a picture of the generic K40 gas laser. The laser has a tube in the back here that creates the laser beam, which is sent around and through into this area, which is then directed down through a lens onto your bed to make your image. As you can see over on the right-hand side, there are not many controls there on this one. Most of it's done through the software when you send the image. There's a fiber laser. Now, I don't know which way I wanted to spell this. This is the way that they spelled fiber in a lot of the images that you see of fiber lasers. These are more expensive, obviously, and they're the image is very, very detailed that you can get from them. But the bed of them is very small, usually. Here's the semiconductor ones. The one on the left-hand side is the one that I think Russ has bought. Mine's practically the same as that one. The one on the right is the Falcon 2, the new one that's come out from Creality, which everybody on YouTube seems to be going for, but it's 4 times the price of the one on the left and does the same job near enough. You can see from the size as well, that you've got 550 millimeters by 580, which gives you, on the one I have, it gives you 400 by 400 burning area, which is more than enough for all my double O gauge stuff that I do. And even I've got a 16 millimeter narrow gauge garden railway, and I make locomotives on this machine for that. The prices, you've got, these are just average, obviously. The K40 gas ones come around £500, way up to, you can get them up to £25,000-50,000. A fibre one is 500 to 18,000, and that is right, £18,000. Diode ones you get from 120 to around 1,000. Now the diode wavelength and the power that you get out of it, along the top there you'll see we've got colour, which is ultraviolet, blue, green, red, and then infrared. And the next line down is nanometers of the wavelength of the actual laser. So 375 to 405. You don't need me to go through all those for you. And you can see underneath you've got the outputs in milliwatts, which is what we're looking at. The ones we'll be looking at usually are 1 or 1.5. The blue is the most common laser color that they use in the diode lasers. So you've got 1 to 5 milliwatts of power to come out of it. The pros and cons of the different wattages here. Pros of 10 watts, suitable for indoor use, compressed laser spot for high resolution, energy efficient compared to other wattage options. Cons, you've only got limited workspace. You can't really make them much bigger than 400 to 500 millimeters in size, and you've got less options on material that you can use. The 20-watt one, you can see you can handle larger areas, classrooms, higher resolutions, deeper cuts, the large range of materials and thicknesses. And the cons, you've got a higher wattage, you've got higher energy use, which obviously is more expensive to use. And the 40-watt one, superior cutting depth and speed, and it can be used outdoors. The 10 and 20 watt have a tendency, if the wind is blowing, for the laser to actually bend slightly. It isn't the laser bending, it's the particles in the air that are actually moving the focus spot around. But the 40-watt ones can be used outdoors, and the larger wattage gives a longer life for diodes. Are there any questions there before we go on to the types of controllers that these things will actually use?
Can't see any in the chat, Bob.
So there's different types of controllers that are used in these machines. And the ones we're talking about, the diode ones, they use G-code controllers. The controllers that you can use for them are GRBL itself, SmoothieWare, Marlin, Fluid, NC, and X-Tool. Now, the X-Tool actually uses an add-in to it, so you can only use X-Tool with X-Tool. DSP, these controllers are mainly used in the K40 type lasers and the mid-range stuff that uses gas lasers mainly. And the different controllers there are Rudy, Tricon, and Top Wisdom are the three main ones. There are a lot more that we use. But that's mainly industrial stuff we're talking about there. And then there's Galvo, which the fiber lasers come into. They have the fixed scan head, and they actually move the image around to create the image that the laser burns. Now, the diode power of the laser varies quite a bit, from milliwatts right the way to the applications of kilowatts for industrial stuff. We'll limit ourselves to 10 to 40 watts for this explanation at the moment. The higher the wattage, generally, the quicker you can cut or engrave, or the thicker the material you can go through. Now, obviously, one depends on the other, so they're both interlinked. The quicker and the thickness. Most of the diode lasers available, the ones that we use anyway, are around 450 nanometers, which is in the blue spectrum. So as Russ found out, you can't cut blue acrylic with one of these diode lasers. They're always rounded, but we'll go into that in later issues. Some of these new lasers that are coming out, as a matter of fact, the Falcon has just released a new laser to plug into its Falcon 2, which is only 2 watts of a wavelength, but it's shifted to 1064 nanometers so that it can engrave on metal directly onto stainless steel, etc., which you cannot do with a 450 nanometer laser. Here's a picture of a general laser. In the box at the top there, you got a diode, a bar array. So you got a diode shining through a transforming lens to a focal point, through a diffraction grating, and then out through the coupler, as they calls it here, which is the lens normally, a piece of glass which just holds the image together. Here's another one of how they actually structure the lasers, the diodes together. Each one of these images down the left-hand side is a diode. And here's the firing pins here. So this one's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lasers, the 10 diodes, sorry, which are all culminated together to give you the output from the condenser lens, to give you a single point output. This is how you get higher wattage in your lasers. So, as I say, I have an Ortur diode laser, so I put this in so people can see. There are 3 new, the Master 3, Master 3 LE, and the Master LE. This Master 3 has an LU2 10 amp laser. So does the LE. Now, I don't know why they brought out the LE compared to the Master, because it's the same right the way through its specifications. But you can see that you get 9.5 to 10 output watts, which gives an electric power watt output of 40 watts. And that's a 10 amp laser. The wavelength is 445 plus or minus 5 nanometers. The spot is 0.05 of a millimeter. It's square, believe it or not, and it comes out, not round. And the focal distance is 50 millimeters. And they're all class 4 laser. You can see over on the right that the LE3 this has got a 2 watt laser, and it only outputs 4.5 to 5.5 watts, which gives an electrical output of 20 watts. The spot size is slightly bigger, and they have 2 different models, way that you can shift the laser on them, the SF and the LF. The LF gives you a focal length of 50 and the SF 30. Now, are there any questions before we go on to safety?
I can't see any in the chat.
Safety, very, very important. We stress this. These lasers are dangerous, very dangerous. You can blind yourself. You can set your house on fire, or your garage, or wherever it is you've got it. So never leave the laser alone when it's working. Always use the safety glasses that come with the laser, because the different lasers have slightly different wavelengths. Your glasses are for your laser. Never look directly into the laser. Be careful of the reflections that you get. It's amazing how you can get reflections from a laser all over the place. Don't modify your machine unless you know what you're doing. But I would say never, ever modify it. Now, things you don't want to cut when you're using your laser. Some plastics are very dangerous to cut. It's important you know what you're planning to use. Some plastics are poisonous and give off poisonous gases. Some actually melt at a very, very low temperature and can cause a fire very quickly. And it's not just plastics either. We'll go through a few just now. So here are a few. PVC, polyvinyl chloride, leather. Now, leather you can actually engrave, but you must remember to have good ventilation when you're doing it. ABS, fiberglass, coated carbon fiber, which a lot of radio control modelers use carbon fiber for the chassis and things like that. Some of the coatings that are on the carbon fiber are very dangerous, very toxic. All of them give off, all the above there give off gases that are poisonous. DPE, or milk bottle plastic as it is, polystyrene foam, polypropylene foam. These all have a nasty habit of catching fire if you don't get your settings right. You can cut them, you can engrave them, but you have to be very, very careful. Materials you can actually work with safely, well, fairly safely, as far as setting fire to something, which is what you're actually doing when you use the laser. Most woods, paper and card, cork, acrylic of the right colors, thin polycarbonate sheeting, Derelin, Captain tape, and cloth. PTFE, non-chlorine rubber. Now, I don't know how you tell the difference in that, so maybe somebody else does. Carbon fiber mats and weave that have not had epoxy applied to them, because epoxy is poisonous, or it can be. Etching, you can etch glass, ceramics, anodized aluminium, painted and coated metals, stone, slate, marble, all sorts of stones and slates can be done. And that is the end of the presentation, gentlemen.